Hello dear students, I welcome all of you in third lecture of our module Superposition of Harmonic Oscillations. Firstly, I am going to discuss about superposition of two perpendicular harmonic oscillations for oscillations having different frequencies, Lissajous figures, and then uses of Lissajous figure. Now let's start our first point. Superposition of two perpendicular harmonic oscillations for oscillations having different frequencies, that is Lissajous. That is to obtain the Lissajous figures. Consider two simple harmonic motions acting at right angles to each other on particle, that is one along x-axis and another along y-axis with amplitudes A and B respectively. The phase difference between them is alpha and frequency in the ratio 2:1. Then simple harmonic motion along x-axis is equation number 1. X is equal to a sine into bracket twice omega t plus alpha, and along y-axis is y is equal to b sine omega t, equation number 2. To solve above equations, from equation 1 we write x divided by a is equal to, by using identity for this term, sine twice omega t cos alpha plus cos twice omega t sine alpha, we get equation 3. From equation 2 we write sine omega t is equal to y divided by b, and by using sine square omega t plus cos square omega t is equal to 1, we get cos omega t is equal to square root of 1 minus y square divided by b square. Also, this sine twice omega t is equal to 2 sine omega t cos omega t, and this cos twice omega t is equal to cos square omega t minus sine square omega t is equal to, instead of this one cos square omega t, we substitute 1 minus sine square omega t, this minus term as it is minus sine square omega t is equal to 1 minus this one, this addition 1 minus twice sine square omega t. Hence this equation 3 becomes, that is we substitute the values of sine twice omega t, cos twice omega t, we get next equation. Substitute the sine twice omega t cos 2 omega to this equation, equation 3. That is x divided by a is equal to 2 sine omega t cos omega t, this cos alpha, plus instead of this 1 minus sine square omega t sine alpha. Then substitute sine omega t cos omega to this equation, we get x divided by a is equal to 2, the sine omega t is equal to y divided by b, square root of this cos omega t is equal to, that is this one, square root of 1 minus y square divided by b square cos alpha plus 1 minus twice sine square omega t is y divided by b, that is y square divided by b square sine alpha. Then transfer this term to LHS. We get x divided by a minus this bracket 1 minus twice y square divided by b square sine alpha is equal to twice y divided by b square root of 1 minus y square divided by b square cos alpha. Then rearranging above equation, we get x divided by a as it is, multiply this sine alpha to this bracket, and then we write this bracket, x divided by a minus sine alpha, then minus minus plus twice y square divided by b square sine alpha is equal to this term as it is. Then squaring on both sides. Now write square of LHS term and square of RHS term, that is this one and this one. Square of this LHS term, we write x divided by a minus sine alpha bracket square plus 4 y raised to 4 b raised to 4 sine square alpha plus twice x divided by a minus sine alpha twice y square divided by b square sine alpha is equal to square of this bracket 4y square divided by b square into 1 minus y square divided by b square cos square alpha. Then this terms as it is, this term as it is, multiply this with this bracket, we write 4x y square divided by ab square sine alpha minus 4y square divided by b square sine square alpha is equal to, from this we write 4y square b square cos square alpha minus 4y raised to 4 b raised to 4 cos square alpha. Then transfer this term to LHS and then rearrange. We get this bracket as it is. Then from this term and from these terms we get this one 4 y raised to 4 divided by b raised to 4 into bracket sine square alpha plus cos square alpha plus this term as it is 4x y square divided by ab square sine alpha, and then from this and this term we get minus 4y square divided by b square outside into bracket sine square alpha plus cos square alpha is equal to 0. Then this bracket is equal to 1, this bracket is equal to 1. We get equation number 4, x divided by a minus sine alpha bracket square plus, from this remaining terms we take outside of this bracket 4y square divided by b square into bracket y square divided by b square plus x divided by a sine alpha minus 1 is equal to 0. This equation represents the general equation of curve having two loops. Then the resultant motion of particle, first case when alpha is equal to 0, pi, 2 pi, then sine alpha is equal to 0. Hence, from this equation 4, we write this sine alpha is equal to 0, this sine alpha is equal to 0. We write x square divided by a square plus 4y square divided by b square into bracket y square divided by b square minus 1 is equal to 0. Then this equation represents two loops, represents the figure of 8 and has two loops. We consider second case for alpha is equal to pi by 2, sine alpha is equal to 1. Then from this equation, equation 4, we get x divided by a minus 1 bracket square plus 4y square divided by b square, y square divided by b square plus x divided by minus 1 is equal to 0. Then I rearrange this term as it is, plus 4y square divided by b square, x divided by a minus 1 plus this terms 4y raised to 4 b raised to 4 is equal to 0. Then rearrange, we write for this term, for this equation, x divided by a minus 1 plus twice y square divided by b square bracket square is equal to 0. Hence, from this equation, we get x divided by a minus 1 plus 2 twice y square divided by b square is equal to 0. Then rearrange this equation. This 2y square divided by b square is equal to minus x divided by a minus 1. That is y square is equal to minus b square divided by 2 into bracket x minus a divided by a. That is y square is equal to minus b square divided by twice a x minus a. This equation represents the equation of a parabola. In this way, the resultant motion of particle traces a curve or loops for different values of phase difference alpha. That is alpha is equal to 0, alpha is equal to pi by 4, alpha is equal to pi by 2, alpha is equal to 3 pi by 4, alpha is equal to pi, which represents a different Lissajous figure is as shown in this figure. Alpha is equal to 0, pi by 4, pi by 2, 3 pi by 4, and pi. This figure shows Lissajous figures for various initial phase differences having frequency ratio 2:1. Now we will discuss about second point, uses of Lissajous figure. In 1857, Lissajous demonstrated that when particle is placed simultaneously to two mutually perpendicular simple harmonic motions, the resultant motion of particle traces its path, which depends upon the amplitude and frequencies of the two simple harmonic motion and phase difference between them. If the amplitudes and frequencies are equal, the resultant pattern traced by the particle is a straight line, a circle, or an ellipse, depending upon the phase difference between the two simple harmonic motions. Thus, a more complicated and beautiful patterns of or curves can be obtained by resultant motion of particle of different frequencies are called Lissajous figures. First use of Lissajous figure. Lissajous figure are used to determine unknown frequency of electrical signals. The following circuit diagram shows to obtain Lissajous figure on CR. By observing the nature of Lissajous figures, if one of the frequency is known and other can be calculated. Here unknown frequency, AC source is connected to Y plate and the known frequency source is connected to X plate. The unknown frequency AC source is given to Y plate and is denoted as Fy. While the known frequency source audio frequency generator is given to X plate and it is denoted as Fx. If NV and NH be the number of loops in vertical and horizontal directions respectively observed on the screen of CRO, then a known frequency its source can be calculated by using the formula Fy is equal to NH divided by NV into Fx. Second use of Lissaj's figure. Lissaj's figures are used to determine the ratio of time periods of two constituent oscillations. If the Lissaj's figure curve touches the horizontal side m times and vertical side n times, then the ratio of this ratio of the time periods is m as to n. Consider the Lissaj's figure as shown in figure. Here Lissaj's figure touches the horizontal side once, that is m is equal to 1, and it touches the vertical side twice, n is equal to 2. Therefore, the ratio of time periods of two waves is 1 as to 2. Third use of Lissaj's figure to determine the frequency of tuning fork. The unknown frequency of tuning fork can be determined if the frequency of another tuning fork is known. Let tuning fork A has unknown frequency N1 and tuning fork B with known frequency N are sounded together to produce Lissaj's figures. As there is a small difference in frequencies of two forks A and B, the phase difference between the two changes with time continuously from 0 to 2 pi. If the complete cycle of the change takes place in t seconds, then the difference in the frequencies of A and B is equal to 1 upon t. Therefore, the frequency of tuning fork A is N1 is equal to N plus minus 1 upon t. Now, attach a little wax to the tuning fork A, then repeat the experiment and note down the time t1 taken to complete one cycle of operation. If this t1 is less than t, then the frequency of tuning fork A is n1 is equal to n plus 1 upon t. And if this t1 is greater than t, then the frequency of tuning fork A is n1 is equal to n minus 1 upon t. Thus, the correct value of the frequency of the unknown tuning fork can be determined. Also, these Lissaj's figures used for, that is, these figures provide beautiful and exhaustive designs which can be used for printing of clothing textile industry. Thank you.